All right, boys and girls, welcome back to the drive-through. Here on another wonderful day. It's a Monday. It's the last day before spring break. I'm super stoked about spring break. Hashtag Pigeon Forge, # Gatlinburg. All right, so I really like this section. This is going to be a weird video because it's going to be a lot of me talking and just writing down notes. I don't know that you'll have anything to write down for this whole video. You just need to understand and get used to using some critical words. So the first 3 words that are really critical when it comes to looking at a large set of data, which is usually going to be done graphically, we're looking for the shape of this data, the center of the data, and the spread of the data. Okay? So look at these staples. They look like a bar graph, which is a histogram, right? So this shape is a very common shape in statistics. Okay? If you just think about how many questions did a student get right on a test. Well, maybe there were 20 questions on the test. And maybe there were these students here that got all of them right. They're the elite students. And maybe there's a large group of students that got 16 of them right. They got 80%. And maybe there's just a small group of students that they only got 12 of them right. And then you could put in 13, 14, 16, 18. That could be a possible histogram. Well, in general, in typical situations, in normally distributed pieces of data, most of the people do average. Some of the people are elite, and some of the people are the worst. I don't know how else to explain it. I mean, if they're going to have an elite category, then you're going to have a worst category. It's just the opposite of elite. Okay? So, this is normal unimodal data right here. Normally distributed unimodal data. Let's take a look at these words. Modes, you've seen that word before, but the mode is essentially how many big bars there are. So that's why I said this one was unimodal. We saw bimodal last chapter. If it's more than that, it's multimodal. Okay? A skewed distribution. A skewed distribution is when some of the data skews off in one of the directions. So this, and you always calculate it where the tail is. If that's your data, this is skewed right. Mr. Tilton says it's like the direction that you are pulling the silly putty. I like that. Okay? Whereas skewed left would look like this. Does that make sense? Here the silly putty has been pulled to the left. It is skewed up. Okay. A normal distribution is when it looks like this. If the data has a normal distribution, the standard deviation measures how far away it is from the median. So that is, for right now, our definition of standard deviation. If the curve is unimodal and symmetric, that's what normal means. Does that make sense? Unimodal, relatively the same on both sides. Then the standard deviation is used to describe the data by how far it is from the mean. So you're going to need to remember that. Okay? Outliers, we talked about those last video, so I'm going to kind of move on, but they're data points that are outside typical measurements. In fact, they are 1.5 interquartile ranges away from the end of the box. And then variability. If the data points look like this, Those are supposed to be dots, ViewSonic. Okay? Then those have a low variability, where if it looks like this, those have a higher variability. It's important to understand that both of these means might be right here, but they're significantly different spread. Okay? And then finally, some graphs are better than others at analyzing the center. So now what we're tasked with doing here is 7 goals. We want to first describe the data distribution for the next 6. And then I can tell you right now we are going to skip these because I think it starts to become kind of redundant and I don't want you guys to not watch the video. So here we go. Alright, so this is Williams's class. And I kept copying this because it wants us to describe this for William's class. Again, I'm just going to jot down notes and use words. So, I personally think it is skewed in what direction, Carson? Good. Skewed right. I think I would consider it bimodal. Someone else might consider all of these the mode and consider it unimodal. I would take either one. Okay? This is a histogram. Okay, shape, center, and spread. Where would the center be, Carson? Let's see. The median could be, the median and the mean, I bet, would be somewhere in this area. Because there's so many more percent of people. Keep in mind, 50% of the people are represented right here. Can you see that? So actually, I can tell you that the median would be right there. The mean, I bet, would be further over to the right. It doesn't look like there's any outliers here, but I don't know for sure because I don't have it in a box and whiskers plot. I can't really tell about the variability because I don't know how close the values are. And that's about all I got. Okay? Alright, so what's it called when there is more than 2 or more than 3 modes? So this would be multimodal, right? This is all of this, and keep in mind these are scores. So in Mr. Lemon's class, it looks like there are 6 kids with 70s. There are 8 kids with A's. This is according to, so there's 12 kids with C's, 8 kids with A's, and all of the rest, let's see, 4, 10, 14, 20 kids with B's. So this is normally distributed, I think. It's multimodal, right?
I don't think it's really skewed.
I don't think there is a lot of skew. So what's it called when it's not skewed? It's either normal or, let's see. I think it might say it later in this, but I'd say it may be normal. Yeah, I think it's normally distributed, especially when you look at the B's, C's, and A's. Most of the people got B's. Some of them got A's. Some of them got C's. And the worst, exactly. Okay, so yeah, I'd say it is normal. Okay, what kind of graph is this? It is a box and whisker plot. So this is nice because I can find the outlier right away. There's an outlier. I can find the center right away. Where's the median? So the median in this problem is about 77%. Excuse me. Okay. This is normally distributed, I think. Most of the data comes between 72 and 90. it looks like there's a much bigger variance, so the spread is wider than it was in this class. Notice, Mr. Lemons, everyone had above a 70.
However, somebody had 100.
Here, someone had 100 and someone else had a 60. So it's a wider variance. Okay? I talked about an outlier. I can't tell if this is unimodal or bimodal. Can't tell from this plot. So now I think we're learning the point of this. Different graphs help us with different things. The box and whisker plot really helps us with center and spread and outliers, whereas a histogram helps us with whether or not it's skewed and shape and maybe some outliers too. Okay, does that look normal to you? I think it's pretty normal. I agree. If this was here, it would be perfectly normal, so it's normal enough for me. So that means it's unimodal, right? And that means, let's see, I don't think it's skewed either direction. Do you agree? We could find our center. I would imagine it would be somewhere around this range. Do you agree? The spread is pretty big. I don't see any outliers. Okay? And I think there's relative high variability in this. It does range all the way from 58% to over 100%. So that's pretty high variability. There's a lot of spread there. All right. Perlier's class goes from 60 to 100. There are no outliers. We can find the center. Okay. I think this is maybe skewed a little left because the left tail is bigger than the right tail, and the second quartile is bigger than the third quartile. So I would say this would be skewed left a little bit. Okay, let's take another look at a different one. Mr. Jones' class, this is skewed left. Remember, the putty has been pulled left. I know it's weird. I taught this wrong for 2 years. I think it personally looks skewed right. But Mr. Tilton taught me whichever way the putty has been pulled, it's skewed left. The putty has been pulled this way. Does that make sense? It's weird. It's just that's just the definition of how they define skewed. The putty has been pulled to the left. Okay? Is there an outlier? Yes. Yes, there is. This one's an outlier, I would imagine. I could maybe calculate the center just by adding up the percents, but I don't know, somewhere in there is the center, I bet. There's a very large range, whether you take the outlier into consideration or not. So there's a lot of spread, which means there's a lot of variability to this graph. Okay? I'm happy that we're getting to say these words a lot. All right. When you see it, what do you say?
It's definitely unimodal.
It's unimodal. Excellent word.
I don't think it's skewed at all.
I don't think it's skewed at all, which means it's normal. It's distributed normal. I don't see any outliers. Okay, I can't either, but look. It looks like that one is a 74.4, and this one is an 86.4. So this is important. Of all the data, this is the most condensed.
So very low.
It's got the lowest variability. Very good. It's got the lowest variability. Very hard to get an A in this class. In fact, seemingly impossible. But also very hard to fail this class. Okay? All right. Number 8. Achievement test scores overall.
No outliers.
No outliers.
Looks like there's normal distribution.
It seems very normally distributed with whiskers literally equal.
Right for what it is, achievement test scores, because there usually should be an outlier.
You'd think there would be some outliers on achievement scores, yes. But not this one. It seems to be normally distributed. It's got relatively high variability. It goes all the way from a 92 to a 58 or so. Can we find the center?
Yeah, it's right here, 75.
There's the center at 75. Okay. We can find our quartiles. Where is the upper quartile at? Upper quartile. Excellent. This is the upper quartile. Those are the top 25% of all the students that took the overall achievement test. Where's the lower quartile at? There's the lower quartile. Okay? Sometimes it's called the fourth quartile and the first quartile. All right, now we're going to compare two graphs side by side. So let's compare Mr. Anderson's class to Mr. Williams' class. Both of them have a very similar lower end score, right?
Yeah, they do.
They both start right below 60%. Mr. Anderson's class has got a higher upper end score. Where are most of the people in Mr. Anderson's class? Where do they lie?
They're in the B's.
Yeah, most of the people are in that range. High C, low B, high B.
Like most people are over here in
We're in this.
C to B.
Most people, nah, I disagree. I think most people are in D to C. So, Mr. Williams is skewed what?
Right.
What type of class do you want to be in?
The one that's skewed right.
Oh, well, you want to be in the right side of this class, but if you were looking at if you were picking your college professor for a math course, would you sign up for Mr. Williams' course or for Mr. Anderson's course?
Probably Mr. Anderson.
Yeah, for Mr. Anderson's course. I mean, over 50% of the people that take Mr. Williams' class are in this range. So more than half the people get a D or a low C. Whereas here, how many people get a D or a low C?
Very few.
Yeah, significantly smaller, more like 20% of the people. Okay? Which one of them's normal?
I think this one's
I would agree.
normal.
Which one of them has standard deviation, though? Which one of them could you find the distance, easily find the distance from the center, from the median?
I think definitely this one. Probably.
The normal one, you can kind of say that since all of the data is split equally,
Yeah, it's probably about there.
there's the median, so we know exactly this data point is about 17 from the median. Where here, it's very hard to figure out where the median would be
Without adding them all
without adding them up and taking it from a graph to a list, right? All right, now we've got really two different types of histograms, I guess you could say. No, this is a frequency chart, and this is a histogram. Why is it a frequency chart? Because there's no
percent.
left axis on a frequency chart. You can see, what is this frequency? This is a 6, oh no, a 4, a 6, a 4, a 4, and a 4. That's how where here you don't know how many, you just know percentage of total. Okay. Which one of them is skewed right?
This guy.
This one's skewed right. Are either one of them normal?
Not really.
I would agree. I don't think either one of them is normal. Which one would you consider bimodal? I agree. This is bimodal. Which one has greater variance? Yes, very good. Next. Both of these are what?
Box and whiskers.
Okay. Which one's got a higher center, a higher median? Well, I don't know.
Looks like
That one's a little less than 80.
Hurl's,
So Hurla's got a higher median. Which one has a outlier?
Cross.
Cross has an outlier.
Laura Cross.
Laura Cross, Tomb Raider. Okay. Which one's got greater spread?
Hurl's.
You think it's Hurla's?
Wait.
It looks like it, but you got to look at it's because of the outlier, right? They're very similar. Neither one of them has greater spread. This one goes from just about 100 to a little below 60, and this one goes from 100 to a little below 60.
That's equivalent.
It is just about it. So there's no difference in spread. Which one would be skewed left? No, I'm sorry. Skewed right.
This guy.
I don't think so.
No.
Let's see. This one's got more people in less spots. So this one goes like this. Then a lot of people here.
Yeah, I think it's Cross. That would be.
I think that one would be skewed right. But I guess what we're learning is from whisker plots, it's really hard to tell which way they're skewed. So I shouldn't even make that comment. Outliers, center. That's best for box and whisker. And that's going to be oh no, we have we have a couple more to compare. All right, now let's look at all of the histograms. Which one has an outlier?
This guy.
Uh-oh. This has an outlier. Which one is the most... Oh, I shouldn't say this. Yeah, I can say that. Which one has the least variance? Spencer's has the least variance. Variance or ants? I don't know.
We're not English teachers.
We are not English teachers. Which ones are unimodal?
This guy is?
Yep.
I think this guy is too.
Yep.
I think they're all.
They're all unimodal. Which ones are normal?
I think this guy's kind of normal,
I agree.
and I think this guy's kind of.
I agree. Those are normally... So then if they're not normal, which way is Mr. Jones skewed?
It's skewed left.
Yes, it is. The putty has been pulled left. I'd say that's enough.
Yeah.
Boom!